such resting membrane potential is achieved. See, this is again the diagram of axon. This fluid, which is called exoplasm, which is rich in potassium ion. Outside fluid is called ECF, which is rich in sodium ion. So there is a concentration gradient. If ions can move from high concentration to low concentration, potassium will move outside because exoplasm is rich in potassium ion, and sodium will move inside because ECF is rich in sodium ion. But this does not happen. The reason behind this is the plasma membrane of axon membrane is a selective permeable membrane instead of a semi-permeable membrane. During resting stage, potassium permeability is more, sodium permeability is less. One more fact we should know: the plasma membrane contains more leaky channels of potassium as compared to sodium. So what happens? Ki potassium efflux is more than sodium influx. It causes accumulation of positively charged ions outside than inside. So due to accumulation of positively charged ions outside, inside of the membrane becomes electronegative. The potential difference of inside at certain stage becomes minus 70 millivolt. When it is achieved, this is called as the resting membrane potential. But due to accumulation of positively charged ions outside, it attracts negatively charged ions, which is not free to move, because negatively charged ions present here are phosphates and negatively charged amino acids, which are not free. They cannot move outside. So exactly opposite event occurs. Positively charged ions start diffusing inside. So when positively charged ions start diffusing inside, the potential difference of inside membrane again increases. It goes below minus 70. Say it goes, it is about 80 millivolt. 80 millivolt potential difference. When potential difference is less than minus 70 millivolt, this state is called hyperpolarization. And in case of hyperpolarization, neuron would not be able to perceive a new stimulus. Then again, resting membrane potential is achieved with the help of sodium potassium pump. Sodium potassium pump operates by a process called active process, means it requires energy, because sodium potassium pump expels ions from low concentration to high concentration. You can see in this diagram, when 3 sodium is expelled, 2 potassium are taken in. Sodium is expelled outside from low concentration to high, potassium is taken inside from low concentration to high, and this is done with the help of an enzyme called ATPase enzyme. ATPase is an enzyme which brings about hydrolysis of ATP. So when one molecule of ATP is consumed, 3 sodium ions are expelled and 2 potassium are taken in. So due to expulsion of more positively charged ions, then the intake of less positively charged ions, again potential difference which was initially minus 70 millivolt is increased. It goes above, it is 70 millivolt potential difference is achieved. A 70 millivolt potential difference is called resting membrane potential.